Our objective for today, I can subtract rational numbers. Let's read it together. 1, 2, 3. I can subtract rational numbers. So, write your objective at the bottom left. The title for your notes should be Rational Numbers. Okay? So, let's see if you remember the definition for rational numbers by yourself. Fill out your Ferrier model, please. I'll give you guys some time for that. In case it doesn't come to mind, start writing examples of what you think a rational number is and a non-example. Don't look at your notes. See if you remember. Go. Okay, here it goes. So, rational numbers, definition. Numbers that can be expressed as a fraction using integers with denominator not equal to 0. Simplest way to put it. Numbers that can be expressed as a fraction using integers with denominators not equal to 0. Those are integers. Okay, examples. There's 3/4, -7/9, 12, 155, -28. -267, but we can also include in here, how about 0.25? Can we write 0.25 as a fraction? Yeah, by writing it over what? 100. How about 0.7? Can you write that as a fraction? Over what? 10. When it's one digit, it's over 10. Okay? Non-examples. Let's see. How about
pi, or square root?
Pi. How about 3/4 x equals 6.
Square root of 6, square root of 8. Square root of
How about square root of 2? Square root of 5. Okay? So, talk it over with your neighbor. Why are these rationals? Why are these not? Go. So, to remember, rational numbers need to be written as a fraction, or can be written as a fraction. They are integers, yes. No zero denominator, and numerical expressions. Steps. Write these down, please. To subtract rational numbers, number 1, use the additive inverse property. Who remembers that one? Add the opposite of the second number to the first. Remember that? Step 2, rewrite the decimals vertically by aligning the decimals. Step 3, if a fraction, then identify the common denominator and rewrite the fractions, then subtract the numerators. Remember we did that yesterday? We were finding common denominators? Yes, Mr. Q. And number 4, identify 0 pairs and simplify. Copy that. Okay? Alright, before we get started though, since we're going to be using the number line again, just to clarify, on the Q side, I want you to write proper fractions. On the Q side. Okay? And then you're going to write all are located between 0 and 1 or 0 and -1. Let's see. Proper fractions all are located between 0 and 1 or 0 and -1. So, can somebody give me a proper fraction? Yes. Very good. 3/4. 3/4 is a proper fraction. Also, how about 2/3? Yes, that's a proper fraction. How about 1/5? Yes, that's a proper fraction. How about negative, I'm going to use same style, but with a negative so you guys can see what I'm talking about in regards to negative proper. How about negative, what is it? 5/6. So, once again, a reminder, for those of you that forgot, proper fractions are all located between 0 and 1 or 0 and -1, and look at the numerator. What do you notice from the numerator and denominator? The numerator is smaller than the denominator. That's how you know it's a proper. So, draw a number line here. So whenever you see proper fractions, automatically you're going to think this. Making the number line a long number line and putting 1 and -1 on each of the edges. So like that, you know that you need to break this down into different regions. Are we there so far? Okay? So what does that mean? What then, if proper fractions are between 0 and 1 and 0 and -1, what do you think improper fractions are located? What is it? No. We said proper fractions are located between 0 and 1 and 0 and -1. So where do you think improper fractions are located? Anything after that on both sides. So check this out. Proper fractions are right here. Anywhere here. So, point arrows to this side and point arrows to this side. And write improper fractions. Improper fractions or mixed numbers are located after 1 and after -1. Does everybody understand what I'm showing you? Okay, because we're going to use this information right now when we get to graphing using the number line, fractions. So, with that said, in the back of your paper, copy this one, example 1A, and write subtract. It says 0.3 minus, parentheses, -1.2. Okay? So let's see. Pens down, eyes up here. And step 1. What does step 1 says, Jorge? Step 1 says, use the additive inverse property. Focus, please. Use the additive inverse property. What does the additive inverse property say? It says, add the opposite of the second number to the first, 0.3. Did we add the opposite of this one to the first? Yes, there it is. So now what do you notice? It becomes a what? Addition. Step 2, read us step 2, Jose. rewrite these vertically. What does that mean? Stack them by aligning the decimals. And guys, pay attention to this. Always place the biggest decimal number on top. So this one is 1.2. Align the decimal of the other one. The decimal goes here. What goes here? 3 and 0. And this became what? Addition. Okay? So this is 5 point, and this is 1. So the answer for this one is 1.5. Copy that. How are we doing? Yes? Questions on this? Let's do another one. Example 1B. Copy this one. It says it's 17.2 minus 4.39. So step 1 again is what, Jorge? What is it called? Use the additive inverse property. So if it's a subtraction, we're going to add the opposite. What is the opposite of a 4.39? Negative 4.39, and to the first. Step 2, rewrite the decimals vertically. What does that mean? Stack them, right? Which one goes on top? 17.2, so you're going to write 17.2, and you're going to align the decimal of the other right there. What goes after the decimal? 3, 9, 4. And what goes here? 0. Alright? So it looks like we can't take away from here, so we're going to borrow one from here, or 10. That becomes 10. This one is
11 because you have to borrow from 7.
1, and then we're going to borrow from 7, so this becomes 11. So this becomes 1, 8, bring down the decimal, and 2, 1. And let's see, absolute value of 17 is 17.2, absolute value of negative 4.39, 4.3, which is the greatest absolute value, this one, so this is a positive, and we're done. Are you getting the hang of this? Yeah, right? Okay. Alright, copy this one down, please. Example 1C. What? No, I'm waiting for people to finish writing. Okay, here we go. One capital A, one capital B. See if you can do those by yourself. Go. For one capital A, we got 0.4 minus 2.2, and capital B, we got 12.4 minus 3.29. Go. Let's see. Step 1, Jorge, what is it called? Use the what? Additive inverse property. So the first thing, I need to use the additive inverse property, which says add the opposite of the second number to the first. Step 2, Jose. Rewrite the decimal vertically. Which one has more digits? This one right here, so that one goes on top, so I'm going to write negative 2.2, and underneath I'm going to write 0.4. If this is a positive, it's a negative, we're going to subtract, right? Yes, Mr. Q. So, borrow one from here, this is 12. 4, take away from 12, that becomes what? 8. Bring down the decimal, 1. And let's see, absolute value of negative 2.2 is 2.2. Absolute value of 0.4 is 0.4, or 0.4. Which of these is greater? So what was the original sign on 2? Negative, so the answer is negative 1.8. Hands if you got that. Okay? Number 2. Once again, step number 1, Jorge. Use the additive inverse property. That means you need to add the opposite of the second number to the first. 12.4. Step 2, Jose. So, once again, Jose, what was it? Rewrite the decimals vertically by aligning the decimals. So which one is greater? The 12. So you're going to write 12.4, and underneath we got 3.29, and it's a negative. This is a positive. Put a 0 here. So watch. Let me show you something really quick. Here we have 40, and here we have 29. Look up, please. Look up to the screen. This is 40. This is 29. How many more from 29 to 40? 11. Very good. And how many from 3 to 12? 3 to 12. 9. So, absolute value of 12.4, that's 12.4. Absolute value of negative 3.29, which was greater, this one, and it's a positive. Hands if you got 9.11. That is correct. Let's move on. Copy this one. It says example 2. In August 2001 at the World University Games in Beijing, China, Jamira Hicks ran the 200-meter dash in 24.08 seconds. Her best time at the U.S. Senior National Meet in June of the same year was 23.35 seconds. How much faster did she run in June? Copy that. You got 1 minute. In August 2001 at the World University Games in Beijing, China, Jamira Hicks ran 200-meter dash in 24.08 seconds. So she ran that in 24.08. Her best time in the U.S. Senior National Meet in June of the same year was 23.35. How much faster did she run in June? So what do I need to do? Subtract. So therefore, check this out. 24.08 minus 23.35. Do we know the process for this? Step 1, Jorge. Additive inverse property, which means you need to add the opposite of the second number to the first. Step 2, Jose. Rewrite the decimals vertically by aligning the decimals. So which one goes on top? 24.08, and underneath we got 23.35. So, let's see. 5 from 8, yes. 3 from 0? No, we need to borrow from here. From 10, 7, and 0, and 0. So, absolute value 24.08 is 24.08. Absolute value negative 23.35, 23.35. Which one is greater? 24. And what was the sign? Positive. So, it says, how much faster did she run in June? So, you write a sentence. Jamira Hicks, be nice, ran 0.73 seconds faster in June. 0.73 seconds is almost 1 full second. Is that correct? It's not 1 second, it's 0.73. It's almost 1 full second. Are you with me? Okay. So on the word problems that you get, make sure you set them up. Same process. Any questions with that? Okay, the last example. Check this out. Not that one. Oh, sorry. Copy this one. Example 3A.
Those?
3A. Okay, let's do this one together.
We add the options.
So, Step 1, Jorge. Additive inverse property, which means we do what? Add the opposite of the second number to the first. In this case, we don't stack them, right? Because they're fractions. We find the common denominator. What is the common denominator? 9, and then it says subtract or add the numerator. So we have -2 plus -5. What is that? -7. Hold on. We're not done. You owe me some time from earlier, right? Okay, just saying. Yes, you do. Here it goes. Next, let me show you with a number line, because I need you to do this for homework. Here we go. Draw a number line. Now, what did we say about proper fractions? They're between what and what?
1 and negative
1 and -1. So right away you're going to do 0, -1, and 1. So now look at the denominator. What is the common denominator on both? 9. That means there needs to be 9 spaces here, which means I need 8 tallies. So I go, watch. I'm going to go half, 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 and half. That is 1, 2, 3, 4, 5, 6, 7, 8. One more? 9. Do that again. 1, 2, 3, 4, 5, 6, 7, 8. So now, check this out. It says here, take away 2 9s. So I start at 0, and where do I go? Left how many times? 2. 1, 2, and I land at -2 9s. But then it says what? Add to this amount another -5 on the same direction. So from here I go left how many times? 1, 2, 3, 4, 5, and I land at 1, 2, 3, 4, 5, 6, -7 9s. Homework for tonight, found on page 79, numbers 1 through 15. Oh, have a good one, guys. Enjoy your homework. See you guys tomorrow.